Hello. Here we have problems related to multiplication, correct? And they are all different kinds and very interesting problems. Now let's try to go one by one. You can note down, copy the questions and try to do them yourself and then go through the video and understand how we are trying to solve them. Okay? This is a good time to stop and copying the questions and then trying them yourself. Once you're done, you can go through the video. Okay? Now let's go through these questions one by one. The very first question here is, if m times n equals to 72, give all possible combinations of m and n. This is a good time to introduce you to variables, right? Always we give you numbers, let's say 3 times 4 is what? You say 12. 5 times 3, 15. But now the question is kind of different. We need 15 as a product. What are the factors, correct? So that means you are like graduating from the middle school, correct? So this is what it is. So here I gave product should be 72. So what are the numbers? Well, so how will you do it? We can start with 1. This best way to start with is 1. 1 times the number itself is the number itself. So we say, well, one of the answers is, let me use this space to write down the answer for this. So we say 1 times 72 is 72. Good job. Now, then we can say it's an even number, so it'll go by 2, right? So 2 times, what is 72? 2 times half of 72 is 36. Okay, 2 times 36, very good. Now 3 times, will it go by 3? If I add 7 and 2, I get 9. 9 can be divided by 3 and 9 can be divided by 9 also. So 3 and 9 both are factors, correct. So let's divide by 3. So 3 times, what is 72? If you don't know, do long division. 72 divided by 3. So say 3 times 2 is 6 and we get 1 and 2, 12. And we say 3 times 4 is 12. Perfect. So 3 times 24. So we write 3 times 24 is 72. Now how about 4 times? 4 times, well, we know 2 times it is 36. So 4 times it should be half of 36, which is 18. Right, let me write 18 here. We're running out of space. Anyway, 5 times it doesn't have 5 or 0 at the end, so it cannot be divided by 5. 6 times, it makes sense. If it goes by 2 and 3, it has to go by 6 also, right? So 6 is also a factor. When we're running out of space, we write 6 times what? Now, if you don't know, we can again divide by 6, correct? So this is a rough word column. So 6 times is 72 and 6 times. 6 times 1 is 6 and we are left with 12. And 6 times 2, 12 times. Okay, 6 times 12. Okay, we have squeezed in another value. Now what? 9 times, oh, 7 plus 2 was 9, so it can go by 9 also, right? So 9 times, what is 72? 9 times, where should I write? Let me write here 9 times, and you go 9 times 8. 9 times 8 is 72, right? Correct. 9 times 8 is 72. 9. Fortunately, next number 10, it will not go to 11, and 12 is already here. So we are done with our numbers and factors. I should have really given you most room here, right? But anyway, 9 times 8. So we can say 9 times 8 is 72. 6 times 12 is 72. 4 times 18 is 72. 3 times 24 is 72. 2 times 36 is 72. 1 times 72 is 72. Correct? You could have drawn this rainbow with different colors, right? Web job, correct? And got a perfect rainbow here this time. There are a lot of factors, right? So give all possible combinations of m and n, which will give you 72. So what are the combinations of m and n? 1 times 72 is one answer. 2 times 36 is another answer. 3 times 24 is one more answer. 4 times 18, 6 times 12, and 9 times 8. And you could also write 8 times 9, 12 times 6, and 16 times this, and 24 times that, and 36 times this, and 72 times this. So many combinations, right? Do you see that? That's very interesting. So we see multiplication as a rainbow this time, correct? Okay. Now let's go through question number 2 and see multiplication this time in a different way. So the whole idea is to appreciate multiplication in its forms, in its beauty, right? That's the rainbow multiplication. This one, a room has 54 seats. If there are 9 rows in the room, how many seats are there? So it's kind of rows and columns. So we have 9 rows in it, right? So there's 9 rows, like 1 row, 2 row, 3 row, 4, 5, 6, 7, 8, 9 rows, right? But if we want seats as 54, then let's say every row has 1 seat, then we'll get 9 seats, right? Correct. If we have another 9 more, 9 more will give us 18, okay? And another row, 9 more, 9 times 3, 27, okay? We want 54. Fourth row, 36, 9 times 4, 9 times 5, 45, and 9 times 6, 54. So we get 5. So rows and column, we get 9 times 6 is 54. So how many seats are there in each row? 6 seats. So we have 6 seats. We say 6 seats in each row. Do you see how we approach the problem? This is how another type of multiplication we have, right? Now we see multiplication in a lot of word problems. For example, Sam's age is twice as his 7-year-old brother. What is Sam's age? Twice 7 years. So we say 7 times 2, which is 14. Wow, Sam's age is good. You know it now. Sam's age is 14 years. Is it okay? Does it make sense? Simple multiplication or doubling this time. Correct? Next question. A product of 2 numbers is 35. What could be these 2 numbers? What will you do? I think you will revert back to question number 1 and follow the same process as we did. Product means what? M times n. Product of 2 numbers. So let the numbers be m and n. So m times n is 35. So what are the 2 numbers? This is exactly the same question as question number 1, but written in a different way. Do you see that? So we can say this: m times n is 35. What are m and n? Let's say product of 2 numbers is 35. M and n are factors, right? And their product is 35. So what are the 2 numbers? Make a factor tree. And this time you can start from way ahead like this, right? Don't squeeze them in. You could write 1 here and 72 here. This time you write 1 and 35, correct? And continue, correct? And get all the possible factors. So let's try to do it. So how will you get that? So we say 1 times 35 is 35. Because 5 is at the end, so you can multiply by 5, right? Second, if we add 3 and 5, you get 8. It is not a multiple of 3 or 9. So those are not the factors. It is not an even number. So 2 is also not factor. 3 is not factor. 5 is our next factor. 5 times 7 is 35. Both are prime. So that is our factor tree. This one, it didn't turn out to be that big, right? So you say, okay, this is our combinations, right? So it is 1 times 5 or, 1 times 35 or 5 times 7, which will give us 35. You could write it the other way also, commutative. 7 times 5 or 35 times 1. Okay, so I hope you learned how we see multiplication in different ways when we do word problems, correct? Next time, if you have similar statements, you will know it's time to multiply and get the answer. Okay, thanks. I hope you enjoyed it. If you have any comments, do put them. I'll be glad to answer them. Thank you.